Hi everyone. Today we discuss about a reduction of harmonics using instantaneous active and reactive power theory based hysteresis controller active filter. So in present days we are facing so many power quality issues at the distribution terminal side. So in order to reduce the effect of non-linear load that will affect the sending end currents. So the burden of the non-linear load can affect the currents of the sending end. So, in order to reduce the burden, we are proposing the hysteresis current control based active filter in order to minimize the harmonics. So, initially I run the models. So, in this paper, we mainly focus on the active shunt filter. So, initially we need to take a look regarding to the without using any shunt active filter. What are the receiving end voltages and currents? I will show you here. So this is before any before shunt active power filter not connected, and also the currents across the non-linear load. It is non-linear by using RL load only diode bridge rectifier. Okay, diode bridge rectifier or else variable speed drives you can use no problem. We can get this type of waveform. It will be purely non-linear load. So due to this non-linear load, the THD value of the load current, I will show you here. Okay. Suppose if you want to look at the variation takes place between the voltage waveforms. So this is the voltage THD value. Before connecting any active filter, the range of the THD will be at the sending side voltage 14.33 percentage, and the load voltage will be the load current will be nearly 22.47 percentage. Okay, nearly 22.47 percentage. So this will affect the sending end currents. So in order to mitigate that current harmonics, we are proposing the active shunt filter. I am proposing with two different controllers. One is PI controller, another one is the ANN controller. This one is ANN controller. Here in ANN control, we are using feed forward neural networks. We having three major type of neural networks: feed forward, recurrent, radial bias neural network. These three are the major types in neural network. So I am using feed forward neural network. So what is the main role of the PA controller and what is the role of the ANN controller? I will show you here. Before going to discuss about the topic, we need to finalize. We need to discuss with active filter. What is meant by active filter? I will show you here. So in this base paper, they already mentioned the design of the each and everything. So here we are regulating the DC voltage with the help of the PI controller in one case, with ANN in another case. How we are going to control the current means with the help of the hysteresis controller. This is the hysteresis controller here. So inside the hysteresis controller, there will be a band limit will be available. It limits the current with the help of the bandwidth. And in this controlling part, we are mainly focusing on the Clark and inverse Clark transformation. Clark is mainly refers to three-phase ABC quantities of a voltage or current signal is converted into stationary reference frame. Okay, this is reference frame actually. So we need to convert ABC to alpha beta. Why we are converting means three quantities to stationary reference frame. Why we are placing this one means we need to control the current. Okay, how we are going to inject the current at the load side with respect to the sending terminal. So that we are going to control. How we are going to control means with the help of the we are proposing instantaneous active and reactive power. So whatever the sensing voltages we are connecting at the load side and at the generation side. That means this one, this volt measurements and the current sensors gonna be help to control the current parameter. So in order to control the current, we are going to initially we are going to convert the three phase ABC quantities to alpha beta terms of voltages and currents, and then we need to find out the active power and reactive power. How we are going to these are the calculations to find out the active and reactive power. These are the formulas. This will be, I mean, active and reactive power will be using in different control strategies. You can refer at anywhere. You just search in internet, you can find it out. Okay. So, and then whatever the active and reactive power, we are connecting to the low pass filter. This one is the low pass filter. So in here we need to mention the natural cutoff frequency of your filter will be as low as you require. Suppose I mentioned here 10, it can mitigate the higher order harmonics, higher order terms. That means it does not allow the higher order elements. Okay, that I mean to say. And then whatever the from here you need to observe the compensating currents. So whatever the currents we need to inject means with the help of these compensating currents we can inject the current into the system. I mean, from here, okay. And then we need to perform the instantaneous, I mean, inverse Clark transformation. From when we are applying inverse Clark transformation, we can get the reference currents. That reference currents is compared with the nonlinear load reference. I mean, low terminal currents, and this is given to the hysteresis current controlling loop. This one is the hysteresis current controlling loop, and then we can generate the pulses, and this is the DC voltage regulation. Okay, this is the DC voltage regulation. Now you just check the waveforms regarding to your base paper. Okay, and the current waveform. This is the sending end current. Okay, you need to check this one is the sending end current. IABC is the sending end current. Initially, without control, without giving any active power filter, active filter, the THD value will be a large as long as you require. I mean, it will be larger value. So, in order to control this waveform into sinusoidal, we are proposing the active filters. This one is the active filter. Then you show the load current, I mean, sending end current should be pure sinusoidal. This is the advantage of the proposed active shunt filter. And what is the major difference between the PA controller and the ANN controller? We need to figure it out. Why? Because I mean, different controllers plays different roles in control strategies. So here, PI controller. Come to the topic PI controller. I will show you the THD values of the PI controller. While using PI controller, the THD value will be 4.50 of the current, I mean voltage, and current value will be 0.09 percentage. Okay, this is the THD value referring to the PI controller. In a similar manner, while using ANN, this one, these are the sending end voltages, and this one is the sending end currents. Okay, so with the use of the ANN, the THD values, take observe here carefully. The THD values will be limited. So previously, while we are taking PA controller at that time, THD value will be 4.5 percentage. While by using feed forward neural network, the THD value will be 1.89 percentage. So the total harmonic reduction will be reduced by using the advanced controller. That is the advantage between the PI controller and the ANN controller. In a similar way, while you are controlling the current means automatically the voltage drop will be reduced. The the THD reduced means you get 0.03. In previous time 0.09 will be there. And this will be there are formulas involved in the conversion of ABC to alpha beta conversion, and then for compensating there is one formula. I will show you that formula here. It is easier to analyze for you for future reference. So this one is the compensating current formulas. These two will be mentioned at that point. And then and this is the inverse of Park transformation. It's also contained having one formula. So this is the major thing regarding to the reduction of harmonics by using shunt active power filter. Okay, thanks for watching.